Good morning, good afternoon, good evening, wherever you are in the world. Probably not in the same place we are, Tom.
No.
I am joined here with Tom Prevost and our colleague in Germany today, Christian Schmied. For this, the end of year webinar. Nobody else got the memo that it was the festive webinar. But anyway,
I don't think I own one of those.
Yeah, you did.
Yeah.
Trust me, I've seen you. So you can see we are not necessarily in a traditional Weidmann location today. Christian is based in our Dresden, Germany office. Good morning or good afternoon, Christian. All good?
Yeah, good morning to you.
Excellent. And I managed to come to Tom's retirement home. Here we've managed to get the nurses and the carers out for the afternoon or for the morning, and I'm here with Tom. Today's webinar will be slightly different. We don't have slides to start with, and we asked you all to send us your questions, and we were fairly overwhelmed with the number of questions we have. So before we start, I just want to highlight that we apologize if we don't get to your question. We just had too many. In addition to that, some of the questions were so good that we've put them on the list for a full webinar next year because we couldn't possibly answer it in a short amount of time, but it's probably a topic that's worth touching on. So with that said, how it's going to work today is I am going to ask from your questions, Tom and Chris, to give us their experienced answers as much as possible. But with that said, we would welcome your follow-up questions. I am here monitoring what is coming in from you guys, or even today, as this is kind of a panel discussion, we also welcome your comments. If you have something that you wish to add, these two guys, and certainly I don't know everything, so if you have anything you'd like to add, throw it in the questions. So in the top right corner, you see the question mark and the box. You can throw it in there. And if it's a valid comment, I will do my best to understand it and read it out to you. So with that said, we will get on and start with the first question, which is around vapor phase drying, which Tom, I believe you are going to take this one. So one of the questions that came in was, what is the impact of vapor phase drying, VPD, on transformer insulation?
Okay. Hello, everyone. So this is a great question. Any time that you use cellulose insulation material, you have to dry it out, and it's agreed in the industry, the best methodology for drying insulation is vapor phase drying. In vapor phase drying, you're drying under a vacuum condition. So because of that, you can dry faster and raise the temperature. And you also use a solvent so that you have very effective heat exchange so that you can heat the core and coil assembly up very effectively. Anytime that you add energy into cellulose, you're going to start breaking it down. And so the big, I guess, drawback or the big debate is how much energy you put into the insulation to dry it out versus which breaks it down, affecting this property we call degree of polymerization, versus how effective it is to have a lower moisture content insulation in your transformer. Some really good information on that was just put together by a CIGRE working group. There's a technical brochure 937. It's condition of insulation as a transformer leaves the factory. Very, very good detailed examination about the effect of vapor phase drying on insulation and what's better, to have a lower DP as a transformer leaves the factory, which means that you've used a lot of vapor phase drying and affected the insulation, or lower moisture content. And I can switch to the end. It's more effective to have a lower moisture content. The DP is secondary. So vapor phase drying is very effective. It allows you to dry the insulation in the shortest amount of time and having the least impact on the insulation properties themselves, as measured by DP and moisture content.
And a question from my side, Thomas, then.
Okay.
So we have a lot of customers who are looking at ways to speed up production throughput. Everybody in the transformer business right now seems to be busier than ever. I guess one temptation may be to reduce or speed up the time in the oven. I guess then that's something that you have to be really careful and precise about. That, you know, if you can save a few minutes here and there, you also have to be very mindful that you're not overcooking and deforming or burning the paper, basically.
No, that's a great point. Again, the advantage of vapor phase drying is, of all the systems to dry it out, it's the most effective, but you're also able to raise the temperature higher than other systems because you remove the oxygen from the process. But there are limits, and that's something that we get involved with Weidmann in our labs quite a bit, where you can measure the properties of the insulation, primarily DP, and contrast that to how fast and how rapidly you apply the heat. The other limitation is that we have a recommendation of raising the temperature of no faster than 10 degrees C per hour. That's more because of the mechanical limitations of the material. Think about a piece of wood. If you throw it in a very high temperature, it'll start checking or cracking. And that'll happen with insulation material as well. You have to have time for that moisture to diffuse out of the material. So that's a limitation on how rapidly you can run your system.
Okay, thank you. Switching gears completely here, Christian, and just so you're aware, these are coming out random. There is no logical order to these questions at all, so don't expect to be able to follow this other than the questions and answers. But Christian is a formidable transformer engineer in our European business, head of technology and innovation for the European, Africa and Middle East region, and spent a lot of time at Siemens working specifically on power transformers. So I want to ask you this one, Christian. So it's a question about lead exits. So we have here in a 420 kV or 550 kV transformer, at the middle exit design, you could use a system, for example, like what Weidmann produces, a Faltenbalg. But the question is there a comparable insulation solution for the top lead exit that's similar to those used for middle lead exit designs?
Okay, first of all, warmly welcome also from my side. I was a little bit surprised about this question because normally these parts are well known in the community. But I have checked personally also our catalog within Weidmann, and I could also not find the other ones, which is not called Faltenbalg. But maybe to shorten this question, yes, of course, Weidmann has such a device, which is not called Faltenbalg. This is called trip-proof seals, which you can mount in a horizontal position on the top of your cover, on the top of your active part, with a similar behavior like the Faltenbalg. So for the Faltenbalg design, this is still or can be still used in vertical position, means mounted in the tank walls of transformers. Weidmann is investigating this part since roughly 1 year now. We are coming more and more to the end of such an investigation, but we have to test also these improved Faltenbalgs. So being also later on suitable to mount in a horizontal position on the top of the tank. So if you are looking specifically for the applications of transformers, of course, which of these both devices you can use is most probably depending on the specification requirement of your customer, as well as also what is kind of, I would call it, standard of manufacturing or installation. So, and also taking into consideration the site conditions for these, to make really the right decision, either to use a top exit lead or maybe to use a mid exit lead. There are also some pros and cons, of course, of both solutions. But nevertheless, most probably this is related and influenced by the specification of the customers. What are the benefits of both solutions? And they are, from my point of view, at least technical point of view, comparable. So both are designed for specific processing and operation conditions, and both have the good opportunity that by using these parts, we will not increase the size of the transformer. So they are proper, or they are able and capable that you will get a proper oil filling under vacuum conditions. And always, and this is the main point, the active part, the windings are protected because you have a protected area inside the tank, which is completely and totally covered. And of course, and this is also the benefit of these solutions, you can transport such transformers with oil, depending on the weight, of course, of such transformers. But nevertheless, it's possible that you have really a good transportation system. So whenever you have such an approach or such a request from your customer, so feel free really also to contact us as Weidmann. So meanwhile, we have in our community also in service, which is called engineering service, engineering consultancy, which takes care on such topics. So means we will most probably customize these parts. And I will take care to check once more again why this part is actually not in the actual catalog in. I hope that we will have it later on in the catalog, and you will find the real dimension of such an mentioned device, which is called once more again trip-proofed CS.
And I do have a comment from our good friend and colleague Christoph Krause, where he just reiterates that the main difference between a Faltenbalg and a drip-proof seal is that the drip-proof seal does not have the same pressure performance as a Faltenbalg.
Yes, this is right. Yeah. Thanks. Yeah.
And so I apologize in advance. We are going to be skipping around here a bit because your questions are flying in. So I am just going to thank you, Christian, first of all, and I'm just going to dip back into the VPD topic with a quick question. Is there a desired maximum percentage of moisture remaining in the insulation after VPD?
Very good question. I can answer that fairly quickly. I'm just going to again point to that CIGRE technical brochure because they address that. But the answer is 0.5% moisture content.
0.5% is the desired maximum that you'd want. That's
the desired maximum moisture content of a power transformer as it leaves the factory, and that's an important, very important criteria. That's not the moisture content as it comes out of the vapor phase. That's the moisture content as it leaves the factory, because there's some subsequent, depending on the factory and the processes, there's always some tightening, retightening of the insulation system that needs to be done after dry out because everything shrinks. And depending on how that's done, there's some moisture reabsorption that happens. So it's 0.5 as it leaves the factory. Yeah.
Okay, thank you. Well, sticking with the high voltage world, I guess, Christian and Tom, both happy for you to chip in on this. The question comes related to HVDC converter transformers. So the question was, or is, are there special insulation design requirements for converter transformers in HVDC systems? Christian, I'll let you go first with that.
Yeah, of course, these kind of transformers which become more and more popular also in the last couple of years because grids behind are asking more and more for DC applications are something special and have a different design, definitely compared with AC transformers. So, I mean, different design from a dielectric point of view, partly also from heating point of view or cooling point of view. and location and placement of windings and insulation parts are also different, because the stress is most probably for DC applications in the insulation parts and not in the oil. So this is the main difference of such applications. So means for this you need really you have to take care that you have the right rules in place. So what we cannot talk about design rules, because they are most probably in the hands of transformer manufacturer. So for us as Weidmann, when we deliver the exit leads for such applications, of course, this is a special part of our business where we have a well-trained community within our engineering departments, which takes care really by several tools and calculation methods, that at the end of the day, these parts are really suitable to withstand also DC application and DC current, DC voltage.
Okay, Tom, anything?
Tom, will you add something
to that? When you're designing an insulation structure for an AC transformer, the stress in that transformer distributes based on capacitance. Your favorite term, the permittivity, relative permittivity of the material. And so we go to great lengths to understand what the permittivity of the materials is and how that changes with temperature. With a HVDC transformer, and I'm going to come back and differentiate a couple types. The traditional HVDC transformer, which we call a VSC, voltage source converter, the stress under the DC stress distributes according to the conductivity of the material, which is a very different property. And so you're looking at the conductivity of the oil versus the conductivity of the solid material. And so the stress will distribute differently according to that. What's even more interesting and challenging is that for a transformer, the same insulation system will see an AC and a DC stress. So you have to look at them both. And then you have this thing called polarity reversal. So again, under this VSC scheme, if you want to change the direction of the power flow, then you change the polarity in the converter transformer. So you have to be able to design a dynamic situation in which the polarity will switch in real time. And so that's been around for a long time. Weidmann has great tools, as Christian said, to simulate that. So that's been a challenge. Lately, there's been a lot of technology introduced where the converter transformers are simplified from a design standpoint. And those are LCC line current converter transformers. In those transformers, you don't have the DC stress that you have in the VSC. But you have to be looking at what the specification is and what particularly the test protocols are, because there are some LCC transformers that because you have some emergency conditions in which you want to use the ground as a return path, say you lose one of your conductors, then there are DC stresses. So it gets really complicated. There's some new, there's actually we'll talk a little bit about standards in some of these questions, but there's a joint working group right now between IEEE and IEC that's looking at revising the standard for HVDC converter transformers. And they're really looking at, they're adding this line converter transformers into the main body of the standards because they're getting more and more popular.
Okay, thank you. And one comment from my side, thank you, Christoph, is that if you are looking at exploring manufacturing HVDC transformers, one key criteria there is that there is double the amount of press board in a DC transformer than an AC transformer. So we'd love to speak to you about your
Yeah.
HVDC requirements.
Yeah, if you look at some of the higher voltage lead exits that we produce, you know, if it's under AC conditions, it would have maybe 4 concentric barriers, and under DC around the same voltage, it's double, as Chris mentioned. It could be as many as 8.
Yeah.
That is good hint, and maybe then I can add one more. So take also care on the mechanical properties. So if you have much more of this material inside, of course, then you have also to take care really that it is mechanically stable enough. And this is, by the way, now also in the focus of Weidmann, that we have extended also our knowledge in the field of mechanical engineering. So it means both electrical, dielectrical, as well as mechanical. So that's why it's so important. And I'm thank you that you mentioned this once more again.
Okay. Keep your comments coming in, even the ones about the fact that I look like I have a halo at times from behind me, or that you will help me find the money to buy a new sweater.
He doesn't deserve a halo, that's for sure, because it is. If you know Francis, a halo is the last thing that you'd have around his head.
That's not true, Thomas.
Maybe something like this.
I do, before we go, we're going to shift gears into a more insulation IEC question. But we did have a question come in that's to do with power transformers, so I thought I'd throw it out there. Do we have any thumb rules for the main duct width in a power transformer? Do we have a rule of thumb for the main duct width in a power transformer?
Do you want that one, Christian, or do you want me to take it, or we both can?
No, we can both. Also, because you are longer within Weidmann, so my answer would be no, we do not have, because this is clearly responsibility of the transformer manufacturer. So of course we can also design and create designs by Weidmann, following our Weidmann rules and tools. So, and then we have to discuss this with the end customers. Our philosophy within Weidmann is clearly that the responsibility of such designs is and stays in the responsibility of the transformer manufacturer. So that's why, from my point of view, I would argue with no. Beside you, Tom, what's your opinion?
Yeah, I think the short answer is no. The longer answer, which you're going to get from me, is that Weidmann has, and I think we'll talk about it in some other questions. So Weidmann has design criteria for stress in oil ducts. So we use the philosophy of minimizing the size of an oil duct, then you can increase the dielectric stress in that area. The challenge is you've also got to have adequate size in these ducts so that you can move oil through them. And if it's, for example, the main duct above or below a winding, then you've got cooling considerations that again is up to the transformer manufacturer on how they're going to, what that minimum duct should be. So we don't have a Weidmann standard that says for a 650 BIL it should be so many millimeters, but we certainly work with our customers to use our design philosophy, the Weidmann curves, and optimize what that distance should be. So I agree, the answer is no, but that's my long answer to it.
Well, and keep this one short, Santa, but I have one other question here on a follow-up to that. How does the duct width change when going from mineral oil to esters? And it's a question from our friends at Doble.
Yeah. So the Weidmann has not published design rules. Of the Weidmann reference curve has been widely published and referenced from mineral oil. There is design criteria that we have used and continue to develop for ester liquids. The same philosophy applies, that the smaller the duct, the higher the stress can be applied. The other important criteria for esters is that it's a much higher viscosity liquid. So you have to keep in mind that you need to have an adequate duct in order for the cooling capability for the oil to flow. So you in many cases, when you're starting a design from scratch with an ester liquid, your primary cooling duct underneath the winding is bigger than a mineral oil. So in that case, that can drive what the total dielectric high to low clearance would be.
Okay, thank you. Well, we need to move on because we're still early in the session here with the questions. So I'm going to move to a IEC insulation lifetime question. So Tom, I'm going to throw this one to you. Insulation lifetime per IEC is 180,000 hours, applicable to all paper brands, ? What is the critical quality factor?
Okay. So it's not only IEC, but IEEE, they both agree on this 180,000 hours, that's 20 years. So when someone asks me what the design life of a transformer is, my answer is 20 years. That 180,000 hours assumes that you're going to be at the design at temperature continuously. So if it's 98 degrees as it is in the IEC world at the hotspot, then that would be at continuous. So for a transformer, we have temperature cycling, and we're certainly not always operating at rated load. So there's loading guides, not only in IEEE and in IEC, that you can use to estimate what the life consumption is of your transformer. To go to the second question, does that apply to all papers? Yes. Okay. So there's different within papers. There's different qualities of papers, obviously, but there's also available in the industry traditional kraft paper, and then there's chemically modified kraft, which is thermally referred to as TUK, thermally upgraded kraft paper. The kraft paper is able to withstand a higher temperature, but the criteria for its life is still 180,000 hours. So what you're able to do is run the transformer at a hotter temperature, but the defined design life is still 180,000 hours. Unfortunately, there's a lot of things that IEEE and the IEC haven't agreed on coming to a lot of these standards, but the 180,000 hours is the same life IEC or IEEE, which is good.
Okay, thank you. Well, we'll leave that one there because I want to keep moving. Christian and Tom, feel free to chip in. We have a question, and for those, I've had a couple of questions. Victor, you're one about new insulation solutions. We will get to that at the end, so I'm not ignoring you and the others that ask questions about that. Technologies, I'm headed to a new question, technologies to slow DP loss, Christian. So what new technologies are being developed to stop DP reduction in insulation paper?
Yeah, a simple answer would be, but I think I'm not sure that I have to tell this. So using Weidmann material, of course, as the best material would be one of these options. But seriously, of course, we can, or there are some investigations running in the last couple of years and decades. So which shows really that you have influencing factors to improve the situation regarding depolymerization. So just to highlight some of these topics. So moisture is one of the enemy of the paper insulation systems. So it means removing the moisture from the transformer. So will also reduce the risk of hydrolysis, which can degrade also depolymerization. So there are advantages and development in the past for, I call it, advanced insulation oils. We have also these natural esters still in place, which are going also in the same direction, really, to improve the situation here. So there were investigations regarding chemical additives, which are also implemented in these oils to get stabilized situation regarding also the cellulose oxidation and hydrolysis, so to preventing also DP over the whole lifetime of the transformer. So one of the important things, and this is related also with some developments of transformers, of course, there are much more diagnostic systems today available where you can measure also such topics directly or indirectly. Fine.
Oh, good.
Are we still in the meeting? Yeah, okay. So I had a black screen shortly. Sorry for that. So monitoring systems, also to start diagnostics, to really see what's going on in the transformer. These are all points with which you can really influence also the DP value of your insulation systems. What Weidmann was doing, and this is coming more in the direction also for new development. So we were asked also by the industry partners, by our OEMs, to increase the temperature level of our papers. So there were also some investigations running where we can reach the temperature level of 100 degrees in mineral oil or in ester oil 140. This is a new product which will come soon from Weidmann for power transformers, where you have still just natural material, just cellulose inside. Of course, reaching higher temperatures compared with kraft papers with thermally upgraded. And with this new development, you have also a direct influence to depolymerization, but you can also play in the transformer field with overload conditions. Means often you have these so-called peak loads from photovoltaic as well as from solar power. Little bit limited, and this we will also not hide in this direction, is of course here in Europe the European directive of eco design. So where you are or where you get some boundary conditions regarding the losses. Means losses are limited, and this could be also maybe influence a decision either to go with these new papers or not.
Tom, anything to add?
I'm just going to add, I mean, a great summary. I just want to clarify, I didn't know that the paper that we're developing is 130 degree in mineral oil.
Yeah.
Additional thermally upgraded kraft has a limit of 120 degrees, so has 10 degrees higher limit. The other point, just in general, and I try to bring up some things between kind of what happens under the IEEE umbrella and the IEC umbrella, or Europe and America. One thing that can be done to slow aging of insulation is to limit the amount of oxygen. And it's interesting in that in Europe, there's more open transformers. They usually use a conservator. It's an oil expansion chamber above the main tank. But that's open to the environment, so that there is some availability of oxygen to get into that insulation system. The standards in IEEE are generally written around a sealed transformer. So that's one other thing to consider from transformer design standpoint is moisture is a big one, but limiting the availability of oxygen is also something you can take care of.
Okay, thank you. And yeah, we did drop there for a second, so I hope that everything's back for everybody. I don't see any comments. We are, Tom, coming from space today.
Yeah, I live out in the country a little bit, so thank you, Elon Musk, for my Starlink system. So Yeah, maybe one of those satellites had a blip or something.
Yeah, it's the first time I've done a webinar from space. So just a couple of comments and feedback to that. Lance, I'm not going to comment on Tom's deer, but I will say that it is not an aramid mix, that paper. It is a pure cellulose paper. And of course, you know, this is, should we say, something that we will reveal more information on in 2026. So you will be able to, for those asking, yes, we will release more information on the new paper that is pretty much, I think, ready to go, right? It's being tested by one of the world's biggest OEMs, and
no, internal testing is already finished, so the results are showing really excellent results. So we are ready for marketing, I would say.
These laboratory thermal life tests take 2 years to complete, so that's done.
Yep. So we will provide more information on that next year. Who knows, there may even be a webinar on that. So we'll stay tuned for that, but we will get more information. Quick question. Speaking of DP loss, maybe I'll just throw this to you, Tom. What is the impact of current work by CIGRE WG D1.76 to update DP measurements and interpretations? And your opinion with IEEE P1084 and the use of terahertz spectroscopy for DP measurement? I mean, I would take that one, but I'll let you do.
Somebody's baiting me on that question.
It was directed at you.
Yeah,
for sure someone's trying to pull your strings.
This is a family program, so I won't use the same words that I used in the IEEE subcommittee in which this was brought up. This is in regards to the second question. So the concept of using this terahertz excitation technology it's something that is in my opinion is in the it's kind of in the development stage at the university level. It's a very new technology that still has a lot of research that needs to be done. There's no commercially available equipment in which you can use this magic gun where you point it at the insulation and it gives you a value of DP for the paper. So there is a request from a group in China that wants the IEEE to look at standardizing this technology. I can't comment on what the status of that is, but in my opinion, for something to be standardized, it needs to be commercially available, and it's not commercially available. The first part of the question was on a CIGRE working group versus on DP measurement. It's widely recognized that there needs to be improved technology for DP, particularly for certain types of craft thermally upgraded paper. There is this new working group in CIGRE that is looking at improving the process. There's one methodology that's been introduced, which is called cold delignification of the paper as preparation for the DP measurement. I like that methodology, and I think that you'll see that being introduced in the new CIGRE recommendation. And ultimately, the way it works in IEC is that CIGRE does the investigation with a working group to see what new technologies there are. And if they write a technical brochure that says that should be adopted, then IEC would open up their standard for revision. So I think that technology needs to be improved. And that's another opportunity, I think, for maybe a joint like a IEEE IEC dual logo document, because the methodology is the methodology. It doesn't matter where it was done in Europe or the US.
Okay, thank you. And just to be clear, Tom, hello, and that baiting was courtesy of Solomon Chang from the Gund Company.
Thanks, Solomon.
So,
yeah, I appreciate that.
I have another quick question, but we really have to keep going. We have not long left. You mentioned O2 levels. How low is it O2 levels have to go to have the positive effect? This person in particular has read that they have to be quite low.
Oof. I don't know if you have a level, Christian, but I don't.
No, me neither.
And I would have to look that up.
Yeah, maybe we have to pick it up later on and give this person an answer in a written form. So I have it not in my mind at the moment. Sorry.
And just to round out this particular topic, I have a comment and one very quick question, Christian, I would like you to answer for me. I know you can answer this one easy because even I remember your answer. First of all, the comment was that for a long transformer life, very simple, or in brief, as dry as reasonably possible at commissioning, and then keep it as dry as possible in operation. I think that's a valid comment. And then the next question that I want a very quick answer, please, Christian. What is the initial water content of high density press board at the time of shipment?
This is from Weidmann 6%, really.
I know there is a standard that gives
there can be a range in the standard between 4 and 7, but Weidmann is delivering these parts with 6%.
Okay, and Christian, while I've got your attention, I want to follow up with another question. I believe this came from one of your former colleagues at Siemens, and I wasn't allowed to give my answer. So, so I will ask you, Christian, for the politically correct answer. How does Weidmann ensure that product quality during worldwide production expansion is guaranteed? And that relates to, I'm sure a lot of you know, Weidmann are investing several hundred million francs right now in building out additional capacity, both at existing sites and the construction of new sites around the world. So the question from Siemens is, how do we make sure we get that right and that our customers continue to receive the same high quality or at least comparable quality from new sites and in general around the world? Yeah.
No, quality is always key, and this is not only valid for Weidmann. This is for each and every manufacturer of material as well as also of transformers. So first of all, and this is mentioned by you, Weidmann is really investing heavily to expand the production capacity. And all these locations and countries are certified, of course, according ISO standards. So which is the highest standard of quality which you can reach today. So our goal is and will be that we have the same quality independent where the delivery of this material is coming from. So it means by ramping up these new facilities in the US as well as in Europe and Asia Pacific. So we have to take care really that we train our new people being on board, that we have to understand also the new slightly adapted machinery, because the previous grow was in the past decades before. Also machinery is developing, there are slightly changes. Therefore, Weidmann has established, I would call it so-called a task force, taking care on all these measurements. So it means if a facility is ramping up, so then the samples, the material will be tested much more frequently. And if there is something visible, we have a technical people available, which taking care really to evaluate and to making decisions how to go forward with this. So until this quality is not reaching our internal Weidmann standard, so we will not deliver these materials out of these factories. So it means with this huge effort which we have now in the technical community as well as also in the quality departments, of course, we can ensure that the delivered quality will be the same, independent from locations and production lines. So what is important also to know is, and this is a kind of management program which is established at Weidmann side. Weidmann management decided to initiate a huge project which is called Weidmann Academy, taking care really on training on regular basis of each and every employee of Weidmann. It doesn't matter if this is a manager, if this is blue collar or white collar stuff. So also with this, we think that we have an excellent opportunity really to bring our people, our workers on the next level, that they have really in common understanding what the products are and what is really the special thing later on in transformer manufacturing, so that we really take care and we are sure later on that the quality is reaching the Weidmann standard, which is the expectation of our customers worldwide.
Great
This
answer.
Weidmann Academy, sorry, I want one sentence more. This Weidmann Academy will be also later on enabled, but this is phase 2, that we also provide these services like seminars externally, once more again, like we did in the past. But the first priority at the moment, by ramping up all these locations, is really to ensure the highest quality standard which we have in Weidmann.
Okay, thank you. And I can only add to that I was in our St. Johnsbury facility yesterday, and there we've expanded by approximately 30% the capacity output of the main board machine there. And again, it is going through rigorous testing before any release. I believe, and correct me if I'm wrong, we've just completed the first round, and my question was, okay, are we going back to full production? And the answer was no. We do three separate production runs with extensive testing with Brad Greaves, who some of you know in the high voltage test lab that we have here in St. Johnsbury, and the same over in Europe. And it really is going on. I saw it yesterday, even though I am still banned from the high voltage test lab due to previous misdemeanors. But yeah, it was.
Francis snuck in there and had their technician blow up, was it an orange?
An orange, yeah. Which has surprisingly strong insulation qualities, far more than you would suspect. But anyway, we can't talk about that because we're running.
Yeah, just one more thing to add to that, and what's really important is that we have very extensive lab capabilities, and we utilize those lab capabilities to test the quality of our product. And as you said, we have internal standards with a new piece of equipment that we have to run it's not taking 3 sets of samples. It's starting up, taking a sample, shutting down, starting up again, we have, obviously it's very important that we maintain our quality as we bring new equipment online.
Okay, good. And I'm going to stop you there and move you all along, because just to comment regarding we talked about the oxygen level, how low you need to go, and you said you would get back to our listener. And the comment there is that there's an old report from ABB that shows an oxygen-free transformer with extended life on the paper, and degassing as O2 levels have to be kept very low. 50% reduction did not show a positive effect. So it'd be interesting to maybe see that ABB report, and also to provide some feedback to Mr. Costinger. Moving on, I am going to limit this now possibly to 2 more questions. So I'm just going to pick a couple at random. So first of all, Tom, I want to go to you and give Christian a break for a minute. We had a question, and I know this is a topic that you like, best indicator of paper life. Is it the DP value or tensile strength? Okay. Which is the better indicator?
First of all, I have to say that, so if you look at the standards for life of paper, particularly what you use as criteria when you're doing one of these long-term aging tests, you look at DP, but you don't look at tensile in and of itself. You look at this parameter called tensile retention. So when you're looking at what the end of life of the paper is defined by the IEEE C57-100, for example, the standard for testing the thermal life, it's 50% retention of the tensile strength. And why I say that's important is that if you're trying to test a transformer that's been in the field and you are able, first of all, to get a paper sample, what's the initial tensile strength? You don't know what it is. You can measure if you're lucky, you can measure the tensile strength of that paper that you remove from the transformer. That's also very, very tricky. So for that reason, my personal feeling is that DP that only needs a small piece of paper, and it's not dependent on how it was folded or wrapped around the conductor or something like that. The DP is a better measurement. It becomes a little bit of a moot point if you're trying to estimate the life of a transformer, because can you get a reliable piece of cellulose paper in order to measure either the DP or the tensile? Where you really care about it is in the hot spot of the winding. And if you're trying to get that out of a transformer that you just take offline and go into the manhole, it's impossible. So, a lot of the standards right now, a lot of the research groups are looking at aging markers, let's put it. One that's been used a lot is furans in the oil. As cellulose breaks down, it produces furans that wouldn't be present in the oil anyways. Furans have some pros and cons and some limitations, and there's some more recent research using methanol, which is another byproduct of cellulose degradation, which is soluble in the oil. So that's the technology the industry's heading in. I know that Lance Lewan from Doble is heading up a working group right now to look at some of these aging markers, and CIGRE has some efforts in that regard as well. So from a material standpoint, I still like DP. I think that the testing process can be improved. We talked about that earlier. CIGRE has an effort in that regard, but DP is a true measurement of how that paper molecularly is degrading. But the technology for diagnostics, it's going to be leaning more on soluble aging markers in the oil.
Okay, and Christian, I would, if we had time, throw to you there, hoping that you'd say you prefer tensile strength versus Tom's DP, but we don't have time to ask that question, unfortunately, because we are very much running out of time. So I'm going to give you, take a breath, Thomas. I'm going to go to Christian first, and this was a question that came in a few times. And as somebody, Christian, that's got, let's say, more than 10 years industry experience, the question is, in your somewhat lengthy career and looking to the future, what's been the most significant development in transformer technology in your time in the industry, and where is the most potential for future development? You have 2 minutes.
This is difficult to answer within 2 minutes. It is also a program which fills a whole webinar, because from now on, I'm more than 31 years in the transformer business, was more than 31 years in the transformer business, of course. So I have seen a lot of improvements, and often we had the discussion, so are transformers really innovative projects or devices? Yes, of course, there are a lot of investigations running during the last couple of years. So we found advanced insulation materials, high-performing materials which were implemented. We had the session of smart transformers where we got real-time monitoring systems implemented in the transformer. I remember very well the topic of environmental friendly transformers with the new liquids, ester-based liquids. also for more sustainability or sustainable material, which is implemented or will be implemented more and more, because this is a huge topic where also Weidmann is dealing. The HVDC applications we have already touched was also in my field. And last but not least, and this was the development of the last couple of years, there are coming more and more digital twins, really to have simulations and diagnostics available on such virtual transformers, to avoid to produce a real transformer which costs a hell of money. Yeah? So this from my point of view are the highlights. So what I see and what is really also for the near future, because overall energy consumption is changing. So we will more get topics like grid integration of transformers. Energy storage is a huge topic where also transformers will play an important role. So we have the huge topic how to store battery-wise or maybe via hydrogen. So therefore also some new applications we will see in the near future. And of course, all other topics related to small parts of transformer like cooling systems, etc. So there will be definitely also new developments which we will see soon, and which will really bring the transformer on the next level. And by the way, just to give you a comparison, so in the previous time where you have installed maybe in 33 MVA transformer medium power size, often customer asking today to implement a transformer in the size of 63 up to 80 MVA in the same space, which is in some of the cases not possible, but in most of the cases it's possible. So it means the design has really improved during these years.
Okay. Thank you, Christian. Tom, you have 30 seconds.
Yeah. As Christian was going through it, I think, you know, in my career, which is certainly even a little bit longer than Christian's, I think more on the transformer life assessment. There's been tremendous gains in looking at DGA technology, both in the laboratory and online. I talked about some of these markers that are, the technology on that is improving tremendously. For part of my career, I worked for Omicron that looked at doing testing of the transformers. So you look at transformers, a black box, and you test it, and there's some really good diagnostic techniques that can do assessment. So, you know, you've got this huge investment in this existing infrastructure, and the industry has really made strides in optimizing that, and then also understanding what you can do to make a transformer last longer, primarily controlling moisture and what you can do with that. So lots of cool stuff on the dielectric side, and obviously the voltage levels continue to climb. China, India are looking at 1100, 1300 kV. 1000 kV is like the norm in China now. It's incredible. So yeah,
that was an engineer's 30 seconds.
Yeah. What was it?
Yeah. Okay. With that said, sorry, Tom, to cut you off.
Okay.
Do appreciate your answer. First of all, thank you all. We hope that this format today, without the traditional presentation, was a good end to the year. We hope
we
that
ordered snow to have in the background.
Yeah, I'm worried about the snow. As my little 4-cylinder car out front, if it snows, I need to get out of here. Yesterday, Tom had to come and rescue me in his truck, sorry. So I do have to get out of this place as well at some point. So look, thank you all very, very much for being with us today. Thank you for being with us all through the year. We enjoy putting these webinars on. We have a team behind us, Greg, Rachel, who do a great job in supporting these initiatives. So thank you very much to them. This will be the last webinar of the year, as you can imagine, but we will be back next year. Christian, we are very sorry that you couldn't join us. But as it's Christmas, we want to give you this. So I'm just going to hand it, if you would like to There we go.
Ah, yes, thank you very much. Highly appreciated.
Yes, you're welcome. So we would like to wish you all a very happy holiday season. Also, we hope you will join us next year. And from all of us here at Weidmann, thank you very much. Thank you very much for your custom, your support, and we will be back in 2026. So cheers and
Cheers.
enjoy what's left of the
Happy
year.
holidays.
Thank you.
Yeah.
Happy holidays.
Bye-bye.